Hello everyone, welcome to my chemistry channel, BL Das Short and Sweet in Chemistry. Also, I want to welcome the students of 11th Science, the topic isomerism in few hydrocarbon. Generally, hydrocarbons, alkane, alkyne, they shows different type of isomerism and in 11th class. So that is why first part we will see isomerism in alkane. Alkane is the parent hydrocarbon where the formula is CnH2n plus 2. And alkane also called saturated hydrocarbon because it contains single bond. Single bond means that is sigma bond, and that means here it is one type of covalent bond. Now covalent bonds are generally sigma and pi bond. The sigma bond is formed by the head-on-head overlapping and pi bond that is sidewise overlapping. Sigma bond that is formed by head-on-head overlapping and pi bond that is formed by sidewise overlapping. Now here the compounds generally in alkane they shows different type of isomerism. What is that? Now again you see isomerism, since it only contains single bond, there is no other functional group, that is why simply it shows chain isomerism. Here you can see what is meant by isomerism. Actually in previous video I have explained what is the isomerism totally, different type of isomerism, and totally it is covered the hydrocarbons for 11th and 12th that is present. That means different type of isomerism and the examples I have explained. That is now it can be easy when I will explain isomerism in alkane. Now here you can say what is isomerism? Compound having same molecular formula but different arrangement of atoms. If different arrangement atoms occurs and if you find the same molecular formula, if you count the carbon, hydrogen, oxygen, other, with the same molecular formula but different arrangement of atoms, also they are having different physical and chemical property due to arrangement of atoms. Now here types, what are the isomerism, different types, and here chain isomerism, position isomerism, functional metamerism, tautomerism, and ring chain isomerism. Now it is not necessary to explain position, functional, metamerism, tautomerism, because here there is no functional group, other things, and position that is here also not required. But all things I have explained in my previous video, isomerism for 11th class. Now we can see alkane, about alkane. Alkanes exhibit chain isomerism. Then we should know what is chain isomerism. Now the isomers differ in the carbon atoms by chain or skeleton. That means here it will differ by the branch one. If the branch you see there any substitution is there and it forms branch, or you can say it forms chain, and that is called chain isomerism. And now there are two types of chain isomerism. Simply one straight line, just like if you want to write C like this. This is called straight. And a branch means here if you write here C and here C like this, then it is branch chain. Now in alkane you know that first carbon, that is CH4. CH4 means singly CH4, and if you go to ethane, that is also singly, and there should be no branch. That is not possible to put any branch in methane or ethane. Now but for 3 carbons also you can see, if 3 carbons, that is also not possible to show any chain isomerism. But here 4 carbons we show 2 chain isomerism, 2 branch 1, and 5 carbons will form 3 chain isomerism. Again see functional isomerism, chain isomerism, functional isomerism, position, metamerism, and tautomerism, ring chain isomerism. That is not possible, that is not shown by alkane. Only alkane exhibits chain isomerism, that is called also you put in branch form. And I will explain with the example. And there are two types, one straight chain and branch chain. Straight chain means there should be no branch, but branch chain means there should be some substitution, or you can say some branch chain substitution is present. And 3 carbon no chain isomerism, 4 carbon here it shows 2 chain isomerism, and 5 carbon 3 chain isomerism. So what is meant by first 1 carbon methane, 2 carbon ethane, 3 propane, butane. Like this, when you increase the carbon, 4 carbon butane, 5 carbon pentane, and you know what is the IUPAC of alkane, and one by one you will see what are the isomerism possible in our alkane. Before going to isomerism example of alkane, first we will see classification of carbon compounds. Classification of carbon atoms in alkane. You already know there are 4 types of carbon atoms in alkane: primary carbon, secondary carbon, tertiary carbon, and quaternary carbon. And students generally confuse with this. Primary carbon means 1 degree, first degree. Though it is called primary carbon, this is the sign of the primary carbon atom. A carbon atom attached to other carbon atom. That means one carbon atom attached to other carbon atom, here like this. And now secondary carbon atom, that means one carbon atom attached to 2 carbon atoms. So here you will see how it will join. That means C1, 1. That means here one carbon atom joins to 2 carbon atoms, if it is the case. And now tertiary carbon, that means 3 degree, 3, that is indicates of the tertiary carbon atom, and a carbon atom attached to three other carbon atoms. And now here you can see carbon atoms. So a carbon atom attached to 3 other carbon atoms, and that is called tertiary carbon of 3 degree, and 4 degree, that is quaternary carbon atom. A carbon atom attached to 4 other carbon atom. Here it will attach to 3 other carbon atom, and here it will attach to 4 other carbon atom. And now it is confusing, it will clear with one example. Now again see what is primary carbon atom? Carbon atom attached to other carbon atom 1, and carbon secondary means carbon atom attached to other carbon atoms, and tertiary means one carbon atom attached to 3 carbon atoms, and quaternary, that 4 degree means one carbon atom attached to 4 other carbon atoms, and this is called that is known as tertiary carbon atom. Now similarly, hydrogens are attached to carbon atoms. Suppose carbon atom is primary, then hydrogen are called primary hydrogen atom. If hydrogen atom attached to secondary carbon atom, and then they are called secondary hydrogen atom. If carbon atom attached hydrogen atoms are attached to tertiary, then they are called tertiary carbon atoms. But in quaternary, there is no hydrogen atom to be attached, because here 4 valence are satisfied by 4 other carbon atoms, and that is why it is there is no hydrogen atom attached to quaternary carbon atom. Again see, hydrogen atoms attached to primary carbon mean primary hydrogen. Hydrogen atom attached to secondary carbon means secondary hydrogen, and similarly tertiary, if hydrogen attached, then it is called tertiary hydrogen atoms. So this is the hydrogen atoms. Now you see one example. Suppose this is the this formula. So now that is called bonded formula, bond formula. You can see it is primary, secondary, tertiary, secondary, primary. Then you may confuse why it is primary. That means I told hydrogen atom attach only 1 carbon. This hydrogen atom only, it is not explained properly by the C and like this. So leave it. Here it can be clear. Now you can say primary degree, primary carbon atom, or you can say 1 degree. Then what is the meaning? Suppose I want to write in terms of formula, then this should be CS3. and this is should be CH, because 1, 2, always see the 4 valency of carbon should satisfy in the structure, and this is CH, CH3, and this is CH2, CH2, CH3. That means here you can observe now it is primary carbon, because here only 3 hydrogens are attached, and primary a carbon atom attached to other carbon atoms. Here it is called primary carbon, and now it is secondary, because second you see here it is attached to 2 other carbon atoms, that is why secondary, and tertiary you see 3 carbon atoms, 1, 2 and 3. So it is a 3 carbon atom, and this is primary because it is only attached to 1 carbon atom. So you can say this is primary, and now you can write here primary carbon. Now it is primary carbon. Now similarly this carbon attached to 3 carbon, that is what is tertiary carbon. Now this also, this carbon only attached to this carbon, now it is called primary. Now again you see CH2, and what is secondary? I told a carbon atom attached to 2 other carbon atoms, CH, here 1, 2 other carbon atoms, this is why it is secondary. Now it is secondary, that is also secondary, then you can understand why it is secondary, because it is attached to carbon atom. Now it is primary because it attached to 1 carbon atoms. Now you can see this is bond formula, and this is called structure formula. Now you can see here why this is called primary, secondary, primary and tertiary. So you can say here what are the chance for hydrogen, what are the possibility for hydrogen. Now this is since the 3 hydrogen are attached to that is primary carbon, that is why they are called primary hydrogen atom. Now here also, since 1 hydrogen is attached to this carbon, and that is why tertiary hydrogen atom. Here also 3 are called primary hydrogen atom, and now 2 hydrogen atoms are attached to secondary carbon, that is why secondary hydrogen atom. Now here also secondary hydrogen atoms how many? 2, and primary hydrogen atoms how many? 3. Now I am going to explain what is the number of primary hydrogen atoms in this structure. Now you can see 2-methyl pentane, where it is indicated by bond formula. This is degree primary, secondary, and this is primary, secondary, this is tertiary, this part is tertiary, and this one primary. Now if I will write in structure formula, this is CH3, and the position is like this, 1, 2, 3, 4, 5. The 5 means pentane, into position methyl group, 2-methyl pentane. Okay, the name is correct. Then you will see which are primary. Now you see it is primary, CH3 primary, and now here it is also primary, and this one also primary. That means 1 primary carbon here, and here. How many primary carbon? 3 carbon. So total primary carbon, that is 3. Now come to total secondary carbon. Now total secondary carbon, this one secondary because it attaches to 2 carbon, and this one also secondary because this one also attaches to this carbon and this carbon. Then how many secondary carbon? That is 2. Now next is tertiary carbon. What is the tertiary carbon? This is the tertiary carbon because here it is attached to here and this carbon, above this carbon. If one carbon is attached to 3 carbon, then it is called tertiary. So it is tertiary. Now simple red digit, that is position of the carbon, and the rounded one, that is the primary, secondary and tertiary, the classification of carbon. Now it is also primary because simply it attached to this carbon. So how many primary carbon? 1, 2, 3, and total secondary carbon 1 and 2, and total tertiary carbon, that is 1. Now you can see the hydrogen which is attached to primary carbon, they are called primary hydrogen. If hydrogen attaches to secondary carbon, and this is called secondary hydrogen. Similarly, if carbon is attached to tertiary carbon, that is called tertiary hydrogen. Now totally primary carbon 3 and one primary carbon can attach 3 hydrogens surely, that is why 3 into 3 9. Similarly, total secondary carbon 2 and secondary carbon only attach 2 hydrogens sure, and that is why 2 into 2 4. And now total tertiary carbon that is 1 and tertiary carbon contains only 1 hydrogen, so the answer is tertiary hydrogen, that is 1. Or you can check also here 1 2 3, that is 9, and there is tertiary, that is 1, so it is 1, and secondary 2 plus 2 4. Now it is clear 2 methyl pentane which contain this number of primary carbon, secondary carbon, tertiary carbon, and this is the number of primary hydrogen, secondary hydrogen, tertiary hydrogen. Next count we will see this structure. What is the name? 2 3 3 trimethyl pentane. 2 2 3 trimethyl pentane. Whether the structure is correct or not, you can see here it is 1, the rounded one only degree, and simple one the position of carbon 1 2 3 4 5. That will be also pentane. Okay, pentane. Now in 2 position there is a methyl group, 3 position there are 2 methyl group. So what is the name? 2 3 3 trimethyl pentane. Yes, the name is correct. And here it is 2 3 3 trimethyl pentane. That one can be done here by bond formula. Now this is primary carbon. How many primary carbon? The total primary carbon is 5. 1 2 3 4 5. Similarly, what is the secondary carbon? Only 1. And what is the tertiary carbon? That is also 1. And what is the quaternary carbon? That is a 1. Now when I have done this one by structural formula, you can check here CH3, 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 CH3. How many CH3? 5. So how many hydrogen? Once primary carbon contains 3 hydrogen, that is why total primary hydrogen 5 into 3, that is 15. Similarly, the secondary hydrogen, now you can see secondary hydrogen that is only 1. So it contains 2 hydrogen, or you can say secondary carbon 1 into 2, total secondary hydrogen 2. Then come to tertiary hydrogen. Tertiary hydrogen, this one only 1, that will 1 hydrogen. So tertiary hydrogen 1. Then come to quaternary. What is quaternary? If the carbon is attached to 4 carbon, other 4 carbon, that is called quaternary. See this one. 1, 2, 3, 4. 4 carbon is attached. That is why, and you observe there is no hydrogen. That means because carbon is satisfied by 4 valency of other carbon, so there is no necessary to add 1 hydrogen here because it is already satisfied. So quaternary hydrogen, that is equal to 0. Again you check here. Primary carbon has only capacity of 3 hydrogen to attach. That is why primary hydrogen for primary carbon can be possible 3. Then only 3 plus into 5. So the primary hydrogen totally 15. Similarly, secondary carbon only 1. That is why it contains 1. Similarly, tertiary hydrogen 1. Secondary 1, tertiary 1. So these are containing only the secondary hydrogen 2 hydrogen, and secondary carbon has 2 hydrogen and tertiary carbon has 1 hydrogen. Don't be confused. Again see, secondary hydrogen 2 hydrogen and secondary carbon is 1. That is why 2 hydrogen. Tertiary carbon that is here, and only it is only 1 hydrogen. And quaternary carbon has no hydrogen because it is attached to 4 other carbon atoms which already satisfy its valency 4. Now here I hope it is clear. If we want to, again I want to say, this is the structure of 2-methyl pentane. If it is CH3, remember, if it is CH3 primary, if it is CH2 the secondary, if it is CH then tertiary carbon and tertiary carbon, and now it is the number of hydrogen according to that it is attached. And here also the 2 3 3 trimethyl pentane. Here also you can observe 5 primary carbon. One primary carbon contains 3 hydrogen. That is why 15 hydrogen primary. And next one, total secondary carbon. Here it is only 1, so it contains 2 hydrogen. Similarly, tertiary carbon contain 1, that is why hydrogen also 1. So secondary 2, remember secondary carbon contains 2, tertiary carbon contains only 1 hydrogen, and quaternary carbon contains no hydrogen. So here it is, that is why this quaternary contains no hydrogen. This is, remember, 40 mean quaternary, 30 mean tertiary, 20 means secondary, 10 means primary. I hope it is clear to you. If any structure is given, you can find according to that. Whether it is CS2, CS3, CH, no hydrogen. Remember, CS3 primary, CS2 secondary, CH tertiary carbon. If only C, only no hydrogen, then it is quaternary carbon. This is known as classification of carbon in an organic compound. So here it is in alkane. So I have explained in alkane how can you find the primary carbon, secondary carbon, and tertiary and quaternary carbon. I hope it is clear to you. Hope you will subscribe my channel BL Das Short and Sweet in Chemistry, and also I may hope you will share and like my channel. And thanks for watching my video. In coming video I will explain the isomerism of butane and pentane hexane like this. Thanks again to all.